Welcome to Civil Engineering for Learners. By Dr.K.Aravinthan. Waste Management. Solid waste collection components. Collection points. These affect such collection system components as crew size and storage, which ultimately control the cost of collection. The collection points depend on locality and may be residential, commercial, or industrial. Collection frequency. Climatic conditions and requirements of a locality as well as container and costs determine the collection frequency. In hot and humid climates, for example, solid wastes must be collected at least twice a week, as the decomposing solid wastes produce bad odor and leachate. As residential wastes usually contain waste food and other putrescible, rotting material, so frequent collection is desirable for health and aesthetic reasons. Besides climates, the quality of solid waste containers on site also determines the collection frequency. For instance, while sealed or closed containers allow a collection frequency of up to 3 days, open and unsealed containers may require daily collection. Collection efficiency largely depends on the demography of the area, such as income groups, community, etc., where collection takes place. Optimal collection frequency reduces the cost by involving fewer trucks and employees and reduction in total route distance. Storage space, example, less frequent collection may require more storage space in the locality. Sanitation, example, frequent collection reduces concerns about health, safety, and nuisance associated with stored refuse. Storage containers. Proper container selection can save collection energy, increase the speed of collection, and reduce crew size. Most importantly, containers should be functional for the amount and type of materials and collection vehicles used. Containers should also be durable, easy to handle, and economical, as well as resistant to corrosion, weather, and animals. In residential areas, where refuse is collected manually, standardized metal or plastic containers are typically required for waste storage. When mechanized collection systems are used, containers are specifically designed to fit the truck-mounted loading mechanisms efficiently. Collection crew. The optimum crew size for a community depends on labor and equipment costs, collection methods, and route characteristics. The size of the collection crew also depends on the size and type of collection vehicle used, space between the houses, waste generation rate, and collection frequency. The collection vehicle could be a motorized vehicle, a pushcart, or a trailer towed by a suitable prime mover, tractor, etc. It is possible to adjust the ratio of collectors to collection vehicles such that the crew idle time is minimized. An effective collection crew size and proper workforce management can influence the productivity of the collection system and have a great effect on overall collection costs. Collection route. Efficient routing of collection vehicles helps decrease costs by reducing the labor expended for collection. Proper planning of collection routes also helps conserve energy and minimize working hours and vehicle fuel consumption. The size of each route depends on the amount of waste collected per stop, the distance between stops, loading time, and traffic conditions. Barriers, such as railroads, embankments, rivers, and roads with heavy traffic, can be considered to divide route territories. Routing, network analyses and planning can increase the likelihood of all streets being serviced equally and consistently, help supervisors locate or track crews quickly, provide optimal routes that can be tested against driver judgment and experience. Waste collection containers. Waste collection containers play an important role in the waste collection system. Their type, size, and location determine the efficiency of waste collection. The size and type of the containers vary with the location and source of generation. For example, residential colonies with single-family households require small containers, unlike commercial, institutional, and industries which require large containers. The size of the containers determines the handling of the containers. Small containers can be handled manually while the larger ones require mechanical handling. Characteristics of storage containers. Low cost. Size and weight. Containers should not be rough, sharp edges. Containers should be inert. Containers should be covered. Strength and durability. The containers should not absorb moisture. Containers that lack the above-mentioned characteristics should be avoided in waste collection as they would create menace, increase the collection cost and decrease collection efficiency. Types of storage containers: stationary containers, hauled/movable containers, communal or public containers. Collection operation: a container should be placed in an appropriate location to ease waste collection. The container should be placed at a distance of 100 to 200 meters. A larger distance between the container and the source of generation will discourage people from dumping the waste into the container. The location of the container will depend on the width and length of the lane/road, ease of collection vehicle to reach the containers, the amount of waste generation and type of source generation, example, commercial, residential, institutional, etc. Traffic congestion. On narrow roads, the collection containers can be placed equidistantly at a distance of 100 meters. The containers can be placed alternatively on either side of the lane. A resident will fail to walk 50 meters to dispose of the waste into the containers. Another disadvantage of placing the container at a short distance would be increased fuel consumption of the collection vehicle. It is always better to place the collection container at the end of the street. This would minimize the collection and the transportation cost. Thank you. Happy learning. See you again.